Welcome to the DTS 3D training tutorial. Let us see how to design trial smiles, 3D printed veneers, diagnostic wax-ups, and other same-day, in-house 3D printable restorations. Before we begin, please ensure that you are using the latest version of the software. To check your version, navigate to Help, About section from the top menu. As of June 2026, the latest release is version 3.3. Let's start by uploading the patient's scans. Click on the file name and wait for the thumbnail preview to appear to ensure that the correct scan has been selected. Alternatively, you can simply drag and drop the scan files directly into the software interface. Next, let's upload the patient's photographs. Please note that patient photographs cannot be uploaded directly into DTS 3D. They must first be imported into DTS Pro, the 2D smile design software. After completing the desired smile design or treatment simulation, save the project file and then import that project file into DTS 3D. If available, you can also upload the patient's face scans. Once all scans and photographs have been uploaded, click Next. The software will now prompt you to trim and smooth the scans. Use the mouse scroll wheel to zoom in and out. Press and hold the mouse scroll wheel to pan and move the scan. DTS 3D automatically detects and selects the teeth, along with a portion of the gingiva. This selection can be customized using the Expand slider. You can also use the Add and Remove brushes to further refine the selected area. Press Done. Repeat the same process for the lower jaw scan. Click Next to proceed to the alignment screen. The software has automatically detected the landmarks required for alignment. The blue point represents the dental midline, the red points represent the canine tips, and the yellow points represent the molar landmarks. If the landmarks have been identified correctly, simply click Done to continue. In some cases, the AI may not be able to detect the landmarks accurately. If this happens, just follow the on-screen wizard and place the requested landmarks manually as prompted by the software. Once the alignment is complete, click Next to proceed to the mapping screen. This step allows us to overlay the patient's photographs onto the 3D scans for enhanced visualization and smile design planning. Use the mouse scroll wheel to zoom in and out of either the photograph or the scan. Follow the wizard displayed on the right side of the screen and mark 3 reference points on the photograph, followed by the corresponding 3 points on the scan. Be sure to follow the indicated color sequence and always place the yellow point close to the midline. After the initial point mapping is complete, click Next to enter the refinement stage. At this stage, our goal is to achieve the best possible alignment between the photograph and the scan, particularly in the anterior region. As you move further posteriorly, you may notice minor discrepancies between the scan and the photograph. This is completely normal, as we are aligning a 3D object with a 2D image. Use the opacity slider to evaluate the accuracy of the overlay. Once the mapping is complete, click Done. Click Next to proceed to the design screen. This is where the actual smile design process begins. Depending on your workflow, you can design trial smiles, 3D printed veneers, diagnostic wax-ups, and other restorative solutions. The Show Hide panel allows you to control the visibility of the different objects. You can easily show or hide the patient photographs, smile simulation, upper jaw scan, lower jaw scan, face scan, and other available elements as needed. This is the split screen view, where the scans can be viewed simultaneously in frontal, occlusal, right profile, and left profile views. This allows us to evaluate the design from multiple perspectives at the same time. You can also switch to the dynamic 3D view, which allows you to freely rotate and inspect the scans from any angle. Let's now open the teeth libraries. Based on the 2D smile simulation template used, DTS 3D automatically suggests the most suitable tooth library for the case. This provides an excellent starting point for the design. DTS includes multiple natural tooth shape options within its library. To insert multiple tooth shells simultaneously, hold down the Shift key and click the first and the last tooth shell. Left-click on a tooth shell to select it. To select all tooth shells, right-click and choose Select All, or simply use the shortcut Ctrl+A. You can scale, stretch, move, or rotate a single tooth shell or multiple tooth shells simultaneously. You can mirror the design from one side of the arch to the other. This helps create a symmetrical smile quickly and reduces the amount of manual adjustment required. With the symmetry option, identical teeth on either side of the arch can be adjusted equally and simultaneously. You may choose to design directly in the dynamic 3D view as well. Simply left-click on a tooth shell to select it and carry out the necessary adjustments. Use the shortcut keys to quickly toggle between the Move, Rotate, Stretch, and Scale tools. Heat maps can be used to evaluate both occlusion and shell thickness. The occlusal heat map helps identify contact areas and clearances. The thickness heat map helps identify areas that fall below the minimum required material thickness. The minimum thickness threshold is fully customizable. For printable restorations, the default value is typically set to 200 microns, 0.2 millimeters. Areas displayed in red indicate regions where the restoration thickness is below the selected minimum value. Thin areas can be corrected by adjusting the shells or adding material during the next sculpting stage. The ruler tool allows you to measure the distance between any two selected points. When designing a mock-up, position the shells slightly outside the original teeth to ensure adequate coverage. Try to achieve the most optimal tooth position during the design stage, as only minor refinements should be required later during sculpting. You can adjust the transparency of a single shell or all shells simultaneously. For a thin and aesthetic restoration, try to follow the natural curvature of the underlying teeth. You may use the simulated smile design as a reference during the design process to guide tooth position and shape. Multiple tooth shape options can be explored and compared to achieve the most aesthetic result. Click Next to go to the sculpting screen. Changes in the sculpting screen should generally be limited to minor refinements. If major adjustments to tooth shape or position are required, it is best to return to the design screen, make the necessary changes, and then come back to sculpting for final refinements. The sculpting screen provides add, remove, push, and smooth tools for refining and customizing the final design. When using the Add tool, try to use a slightly larger brush size and a lower intensity setting. This helps distribute the changes over a larger surface area and prevents localized distortions of the tooth anatomy. To add material, simply left-click and hold, then move the mouse over the desired area. The push-pull tool functions as a free-form sculpting tool and can be used to reshape either the entire tooth or specific areas of the restoration. The smooth tool smoothens surface textures and blends modifications. The remove tool is used to remove material from the shells. A higher brush intensity can be used for faster and more efficient material reduction. For one-click trimming of palatal shell material, use the AI Veneer Trim feature. The software automatically selects the desired shell area, and all material outside the selection is trimmed instantly. The selection can be further refined using the brush tools if needed. All sculpting tools can also be used on the original patient scan, just as they can be used on the shells. However, any modifications to the patient scan should be made with caution, as improper changes may lead to fit issues in the final restoration. For a passive fit of the shells, blocking undercuts is mandatory. A 45-degree path of insertion is generally optimal. Click Confirm and review the detected undercuts. Then click Block Undercuts. The software automatically blocks the undercuts and applies a default offset to ensure a smooth and passive fit. Once the undercut blocked model is created, minor shell refinements may be required. After making any refinements, be sure to reconfirm the shell thickness using the thickness heat map to ensure all areas meet the minimum required thickness. Press the Separate Shells button to create 3D printable snap-on shells. The shells can be exported either as a single piece or as individual units, depending on your workflow requirements. If you want to export a wax-up model, there is no need to separate the shells. Simply proceed to the Model Builder screen. You can adjust the base height, choose a solid or hollow model, and add drain holes as needed. Text can also be embossed or engraved on the model base. You can export the printable model with the base, or export the scan and shell design without the base, as needed.